Okay, at this point I hope you've watched part 1 and part 2 of this 3-part series, and probably before those 2 videos you probably want to go back and watch the video entitled What's an Inverse, to get a general idea of what this thing even is, this concept. And I also went through a really good couple-minute video, really short video on what inverses look like graphically. So in this video we're going to go through a couple examples here. We're going to wrap this up. This is our last video in the 3-part series on how to find the inverse of a function algebraically. On the screen is number 7. We've done 6 examples already in the first 2. And in number 7 you see that it's asking a slightly different question than the previous 6. This is asking, are these 2 functions inverses of one another? And there are a couple different ways to confirm that. You can get your graphing calculators out and see that, make sure that these 2 equations, these functions, are symmetrical across this line y equals x. Right? If they are, then they're inverses. But sometimes it's not easy to see, or sometimes you might not have a graphing calculator around, so we want to have algebraic ways to confirm this. And I think I'm going to show you just the composite way. Yeah, I can take this and literally find its inverse, like we did in the first 2 videos. And if I get this, then I'm good. If not, then I'm not. So maybe I'll do that really quickly. Let's just take this top function, and I'm going to just fly through this. Let's find the inverse of this. So I'm going to replace x and y, just switch them, and solve for y. So let's get this one over here first. I always recommend adding and subtracting before you do any of this multiplying and dividing. A little trick here: if the variable that you're looking for is in the denominator, just switch it with this thing. Just move it on over there. So this is y minus 1, and now the x minus 1 goes over here. So I get negative 2 over x minus 1, and then this negative 1 comes back over, plus 1. And that is my inverse. So I'll call that H inverse. We use that little notation, negative 1. Is that exactly what I have here? Well, visually not exactly, but let's see if it mathematically is true. Let's see if this is precisely the same as this. So I'm going to notice that I have the same number in the back. That's good. I have generally the same numerator in both. That's good. The only difference is my negative right here is in the top, and then down here it's negative down here. So hopefully you have sort of a general sense that if I take a negative out of here, out of the bottom, it turns into that. And a negative can go out front of the fraction, or it can go into the numerator of the fraction, or obviously the denominator. Right, so now you can probably see that indeed this function and this function are precisely the same. So this answer would be yes, these functions are inverses of each other. Another way to do that would be to compose h with f. If you compose h with f, you should get x. Similarly, if you compose in the other direction, the other order, you should get x as well. And if you're looking for some more clarity on that, you can either maybe watch my composite functions video, or I do a lot of composite checking in parts 1 and 2 of this series, so check those out. Moving on. What is the inverse of this thing? Alright, so let's do this. Let's go 2x to the third plus 3 equals y, I just basically turned f of x into y. And now I switch my x and my y and I solve for y. So I'm going to subtract 3 from both sides, and I'm going to divide everything by 2. To get rid of a cubed, I take the cube root. And I'm done. I don't want to write y though, I want to write f inverse. There you go. I claim that these two are inverses of each other. You have a lot of different ways to check using your graphing calculators. You can simply just plug in a number. You know, f of 1, for example, is 2 times 1 to the third plus 3. That's 5. And if that's the case, if 1 comma 5 works in my original function, then 5 comma 1 should work in this one. So let's check that. Let's see if we plug in 5 to our inverse, are we going to get 1? That's our sort of little mini task here to confirm. So we have cube root 5 minus 3 over 2, cube root 2 over 2, cube root of 1 is 1. So it checks out. In the original function, 1 comma 5. In the inverse, 5 comma 1. Very nice, very nice. Moving on, this will be the last example. Let's find the inverse of this thing. Let's find the function that sort of undoes the original one. So let's replace this with y, switch the x and the y, and switch these two, right? The old sort of switcheroo trick. We want to take the square root of both sides. Remember, when you take the square root of both sides, you have to take the positive and the negative. That's true of fourth roots and all even roots. For odd roots, you don't have to do that though. So we have a positive and a negative, a principal and a negative square root of 2 over x. And just beware of the fact that this has a positive and a negative. A lot of times it's not actually going to be a function. So this function has an inverse, but sometimes that inverse isn't even a function. But nevertheless, we have found our inverse, right? G inverse is the positive and the negative square root of 2 over x. Right? And to make that a little bit clearer, if you think about if we have f of x equals x squared, the inverse of that is not just the square root of x. It's got to be positive and negative. Alright, and when you take positive and negative square root of x, you get a graph, a relation that's not even a function. Alright, this thing graphs like this. Alright, so if they're residing sort of on the same coordinate system, they would kind of look like this, something like that, right? And they're symmetrical across this line, right? So this guy right here is not even a function. It's not a function. It is an inverse, but it's not a function. So just be careful of that. In any event, that should wrap it up for this 3-part series. I'm sort of debating on whether I should maybe go through this process right now. Maybe I will. I'll just take a few more seconds. If you don't really need me to, if you don't even need more practice with composite functions, you can of course just skip on to the next video. But I'll spend about 2 minutes here going through this for students who need a little bit more practice confirming these inverses. So here we go. Let me clean some of this up first. I want to get on my screen just the function and the function's inverse. So we already said that these are inverses of each other, so let me just clear all this stuff out of here. And what I'm going to do is confirm that these two right here are in fact inverses. Right? We looked at we actually found the inverse of h and figured out that it is this. But let's say we didn't want to do that. Let's say we wanted to compose them. So when we compose, let's do this composition first in this order. So we're going to write h, so it's -2 over x minus 1. But the x in this case, we want to replace with this whole thing right here. So I might need to write this whole thing bigger actually, because it's a compound fraction. So I'm going to rewrite h, so it's -2, and then there's a +1, and there's a -1. And instead of x, I'm going to I'm going to compose it with the function f. So it's 2 over -x plus 1 plus 1. Alright, so let's clean this up. And remember, if these two are in fact inverses, we should get that this simplifies down to x. So here we go. I'm going to put that negative up in the top. My plus 1's over here. The denominator, they kind of simplify to 0. So it's 2 over -x plus 1. Alright, so we want to clean this thing up. Got to do some algebra. Our goal here is to simplify this whole thing down to just x. So let me just deal with this fraction first. Right, that fraction first, I'll kind of take over to here and I'm going to rewrite it horizontally. When I have compound fractions, sometimes it helps me to write them horizontally. -2 divided by that thing. I'm going to keep it, switch it, flip it. Keep this, switch to multiplication, flip this over. Keep it, switch it, flip it. That's how we divide fractions. So now I have -2 out in front, 2 down bottom. So that turns into -1 times this. The 2's kind of cancel out. So if I distribute that negative in, I get x minus 1. So this whole green thing simplifies down to x minus 1. And remember, there's this plus 1 out here, and what do you know? X minus 1 plus 1 is x. That's good. And it should work the opposite way too. So we just confirm that. Let's confirm this right here. Going in the other direction, I'm going to move this whole thing down a bit so I can get some more space. Let's compose it in the other direction. So we're going to go f first. So I'm going to write the function f. But instead of the x variable, I'm going to put this entire function in there. I'll just put that negative, I'll put this negative up in the top. Alright, so for clarity, this x got replaced with this entire function. We're composing it, we're sort of nesting it in itself. And let's simplify that bottom. We can, alright, so I'm going to take this negative and just kind of distribute it among both of these terms. So that turns 2 over x minus 1 minus 1. And we have this plus 1, and then we have this plus 1. It's a little bit crazy. Simplify a little bit more. Let me give myself some more room here. Let's see, let's clear these out. That's 0. So now we're left with 2 over 2 over 2 over x minus 1 and a big plus 1. Again, rewrite it as 2 divided by 2 over x minus 1. Keep it, switch it, flip it. The 2's cancel. We're left with just x minus 1. So this whole craziness right here simplifies down to just x minus 1. And then we have plus 1. And what do you know? X minus 1 plus 1 is just x. Thank goodness. That was a little bit crazy. A little bit more complicated than I thought it was going to be. But composing functions is a really important and kind of very basic way to figure out if a function and its inverse are indeed a function and its inverse. You can also check, again, graphically. They should be symmetrical about this line, y equals x. and you can just kind of pick numbers and see if, if f of, like I said earlier, if f of 1 is 5, then f inverse of 5 should be 1. Right? You get a nice sort of crisscross sort of pattern there, right? And that kind of comes back to what I said earlier about the fact, in my graphing video, the fact that all you really do is you just kind of switch your x and your y when you're graphing these things. All right, that's enough. That finishes part 3 of my 3-part series. So thanks for watching, and make sure you subscribe so you don't miss any videos.